Okay, when you are ready, raise your hand, please. Yeah, you ready? You good? Okay, so for series, geometric series is adding up all the terms. So for example, here we have S5, right? S5 means adding up these 5 terms. So what's the ratio for this series? Cindy?
3.
Yeah, okay, very good. Each time you need to multiply by 3, right? So let's put that on the side. So we want to use this example to try to derive a formula, okay? So that we can find the sum, right? Series means the sum more quickly, right? Suppose I change the question to S50, right? Adding up 50 terms. So there should be a pattern should be a way to find the sum faster instead of adding one at a time. Okay, so let's go to the bottom space here. So here we're gonna derive the formula. So we'll start by rewriting the series again, okay? So everyone can write it down as well. So S5 is 2 plus 6 plus 18 plus 54 plus 162, okay? And then we are going to take the same series and then multiply by the ratio again. Okay, so it will look like this. 3 times, because ratio is 3, right? So 3 times S5. So if I do that, then every single term will also multiply by 3, right? So 2 times 3 will give you 6, right? 6 times 3 give you 18. Right? So it's kind of shifting all the term by one more, right? Plus 54, 54 is 18 times 3. And then 162 is 54 times 3. And then what is 162 times 3? Donna?
486.
486. Okay? So the total for the second line is 3 times the total of the first line, right? Because every single term got multiplied by 3. Okay, any questions so far? So now what we are going to do is, because you can see that in the middle, there are terms that's the same, okay? So if I subtract, okay, I do a subtraction. So I would have, on the left side, it will look like this, S5 minus 3 S5, right? And then on the right side, the 2 will subtract the 0, right? So it will be 2. 6 subtract 6, so these will be gone, right? 18 subtract 18, 54 subtract 54. So these are all gone. So you will just have the last term, which is 0, 0 subtract 486. So negative 486. Okay, do you follow so far? All right, and then on the left side, because they both have S5, okay? So S5 is a number, right? So I can do factoring, just like GCF, common factor. So I will factor out S5. Then what is left in the brackets then? Eric?
Negative 480.
No, I mean on the left side. Focus.
Oh, sorry. Negative 2F.
Negative, what did you say?
2.
Negative 2, yeah, okay. Or you can write it as 1 minus 3, right? If you think about S5 going in, right? If I multiply in, then you get back to the previous line, okay? So here we factor the S5 out, okay? And then on the right side, what I want to do is to factor the 2, okay? So 2. If I take the 2 out, that means each of the term has to divide by 2, right? So what's left inside then, in the bracket on the right side? Tiana?
One minus 243.
Yep, very good. Okay, so each one of them divide by the 2 that you take out. Okay, all right. So our goal is try to find S5. So I'm going to divide the 1 minus 3 to the other side. Okay, isolate S5. So we have 2, 1 minus 243 over 1 minus 3. Okay, so now, right now, so far, we see some number that related to the original series, right? Because you can see the 2 represents the first term, right? And then the 3 represent the ratio. Okay, now we have one more thing that's interesting here, right? The 243, what do you think that number came from? How can we get a 243? How is that related to the series? Okay, I'll give you a moment to think about this. Does it have to do with the first term, last term, ratio? How can we get the 243? Anybody? Okay, did anyone figure out where the 243 come from? Ray, what do you think?
I don't know.
Not sure. Cindy?
I don't know.
Okay, anybody else? Kelly, what do you think?
I don't know.
Not sure. Okay, let's trace back, right? So 243 came from, like previous line was there, right? 1 minus 243. And then the 243, we got it after we take out the 2, right? So it kind of inside the 486. So you think about 486 then. 486 is same as 2 times 243, right? 2 times 243, that give you the 486. That's why we can factor out the 2, right? They both have the 2, so we take it out on the outside. So now you go back and look at the series at the top, okay? 486 also appear here. So since 2 times 243 give you 486, then let's think about how we can climb the stairs, okay? Think about the stairs again. Okay, the 2 is down here. If I multiply by 3, right, times 3, I will get 6. Next one will be 18. Next one will be 54, 162. And then the next one will be 486, right? So each time I need to times 3. So if I want to get to 486, how many times do I need to multiply by 3 then? Anybody? Count the stairs. How many times? Anybody?
5.
5 times, okay? Let's count. 1, 2, 3, 4, 5, right? So that means the 243 is, right, is 3 to the 5. right? 2 times 3, 5 times, it can give you 486. Okay, so there we go. 243 is same as 3 to the 5. So if I rewrite it again, okay, on the next line, I can write it as 3 to the 5. So now if you look at all the number inside, everything is connected to the series now, right? So the 2 is the first term, right? The 3 is the ratio, which is also here, ratio. And then the 5, what's the 5 then? What's 5 got to do with the series? How do we know it's 5? Why not 7? Why not 11? Why 5? Anyone? Does it always have to be 5? Why is this one 5? Eric, what do you think?
Because you multiplied 2 by 3 5 times, so that's also 5.
Yeah, and what about you look at the series? How many terms are there? Look at the original question, that's 5.
5, yeah.
5 terms, right? So
Yeah.
if you give you a question, they ask you to add up 11 terms, then you will put 11 as the example, okay? So the 5 tells you how many numbers you want to sum up. All right, so we got everything we need. And 1 is always 1, okay? 1 minus is always there. Okay, so let's write it out in general form then, okay? So if I want to find Sn, it will be A, right, the first term, times 1 minus the ratio, right, to the number of terms you want to add up, divided by 1 minus R. All right, so this is our first formula. So please fill into the top, okay? Sn equal to A. Okay, please raise your hand if you finish copying all these. Okay, so now let's look at the formula again, okay? Because there's another formula, just like the sequence, right? We also had 2 formula, but then we have the second one was better, right? Because you can start with any place. Now for this one, we also have 2 formula, but then both of them are important, okay? Depending on what's given, okay? So if you look at the formula, what's inside? If you want to use this, then you must know the first term, right? And you must know the ratio, okay? You also need to know the number of terms, okay? So you need to know 3 things in order to use it. Now let's try to get another formula, okay? So I'm gonna grab this one. Let me see, okay? Let's grab, okay, let's take this one. Okay, the green box, I'm gonna put it over here. Okay, you guys can draw a line in the middle. So I'm gonna copy that over here again. Okay, and then over 1 minus 3. So the reason why I want to choose 2, 4, 3 is, okay, I'm going to multiply, okay, change the look a little bit, okay? So instead of taking out the 2, I'm going to multiply the 2 in, okay? So now it will look like 2, right? 2 will go in. So 2 minus 2 times 2, 4, 3 over 1 minus 3. right? Okay, and then I'm going to make a little thing, make a little adjustment here again, okay? Let's wait for the ambulance to pass. Okay, so now if you look at the stairs, okay, I would like you to look at the stairs again. If I climb 5 times, then I will reach to 486, right? 2 times 3 to the 5, I will give you 486. But then 486 was not in the series, right? It's kind of on one extra term, right? So that means if I multiply by 4 times only, then I will reach 162, right? Times 3, times 3, times 3, right? If it's 4 times, it will get to 162. So I want to rewrite the 243, because we know 243 is 5 threes, right? So I'll write it at like this. Okay, the 243, I break it apart into 3 to the 4 times 3 over 1 minus 3. Do you understand what I did here? Can you raise your hand if you know why, okay? If you understand how they equal each other. 243 is 3 to the 5. I just pulled it apart, okay? Instead of writing 3 to the 5, I write it as 3 to the 4 times another 3, okay? So why do I want to do that? Because if I multiply the 2 by 3 4 times, it can reach the last term, the 162, right? The 162 here is 2 times 3 to the 4, right? 4 times. So that means this part, the yellow part, okay, represent the last term. 2 minus 162 times 3. Okay, so this is the form I want to use. So if I look at the form now, the 2 represent the first term, right? And then the 162 represent the last term. The 3 is the ratio, right? 3 is the ratio. Okay, so you can compare the color, right? Yeah, yellow part is the yellow part. Okay, so if I write it out in general, let's put it back here, okay? Then we have our second formula. We'll talk about when to use each one, okay? So the S5, Sn will be A minus last term, so L, times ratio, right, the 3, divided by 1 minus R. Okay, that's our second formula. Okay, you can raise your hand when you finish copying. Okay, so that's how they figure out the two formulas. Okay, Samantha, Kelly, are you done writing? Yeah, okay. So now let's take a look, okay? Look at it, now you know where they came from, right? We need to know what kind of question use number 1, what question you need to use number 2, okay? So you can see that they both have A, right? First term, needs to know first term. And they both have the ratio, right? So you need to know ratio for sure. So the difference is the number of term and the last term, right? That's the difference between the two. So you will be using the first formula, okay? You can write this down. Use when not given the last term. Okay, if you don't know what the last number is, you will use the first formula. Okay, and the second formula, because it has an L, so you will use it when given last term. Okay, any questions? So it's pretty straightforward, right? You just need to look at what's inside the formula, then you know when to use each one, right? You don't have the last term. There's no place for you to plug into the first one, right? There's only the second one has the L. So you can copy to the top now, okay? So Sn equal to A minus Lr over 1 minus R. So of course you don't know how many terms there are. You just know it stops somewhere. So it's like I cross out all these, right? You just know the first one, right? You just know the last one. You are still able to figure out the sum. But of course you need to know the ratio too, okay? So we're gonna try a few questions on the next page. Okay, so question 18. Okay, we'll do the, you will need your calculator. All right, so everyone grab a calculator out. So for question A, do we use the first formula or the second one? Okay, if you think it's the first one, can you raise your hand? If you think it's the second one, don't raise your hand. Okay, so first formula, right? First formula, if you don't know the last term, right? So this one, it goes on, but we don't know the last one. Okay, so we use the first one. So we'll write out the formula then. We want to find the first 12, right? First 12 terms. So we write S12, okay? And then A times 1 minus R to the N over 1 minus R. Okay, so you guys can fill this in and we'll check answer, okay? So I think the difficult part is typing into calculator correctly, right? Because subbing in should be okay. And you need to figure out what the ratio is first, okay? On the side, find the ratio. Okay, if you found the answer, please raise your hand. Okay, let's fill in the blanks. First term is 66. Okay, what's the ratio here? Tiana, what's the ratio?
1/3.
Yep, very good. 1/3. And then the number of term is 12, so we put 12 there, 1/3. If you want to type the whole thing into calculator, okay, it will be, remember to put a bracket around the bottom part, okay, so it divides the whole thing in the denominator. Okay, please raise your hand if you got an answer. Okay, so what do you have? Donna? Donna, do you have an answer? Is your mic working? Okay, how about Kelly? What do you have?
I'm still typing it into my calculator.
Okay. I mean,
21 point or 22.
22 after rounding. Yeah. Okay. Anyone else? Eric, how about you?
I got 98.9998.
Okay. I'll double check. Okay. Tiana, how about you?
I have the same as Eric.
Same as Eric. Okay. Cindy?
Same as Eric's.
Yeah. Okay. So Kelly, double check the typing again. Okay. See if we can get the 98, the answer for 98.
Yeah, I got 98.
Okay. Okay. Yeah. So do you know what you did wrong before?
I hit divide instead of minus for
Oh,
1 minus 1 over 3.
Okay. Okay. So 98.9998. Okay. So that's your sum. So I'm not sure if you can turn that into fraction. Yeah, this one you can. Okay, sometimes you can turn it into fraction. This one is difficult because the exponent is too big, okay, to the 12. So the calculator doesn't handle that. Okay, let's try one more, okay, question B. So this time I won't write anything, okay, we'll just let you guys try it and we'll check answer, okay? Raise your hand when you finish B. Also S12, okay? Sum of the 12 terms. You need to get the ratio first. Donna, what's the ratio?
-2.
-2, very good. Please raise your hand if you found the answer. All right, let's check some of your answer now. Ray, what do you have?
Negative 105.
105, okay, so nice number there. Cindy, how about you?
The same.
The same? Okay, Tiana,
Same.
same, okay. Eric,
Same.
Yep, okay. Yeah, so sounds good. Okay, so these kind of questions very easy as long as you type it in correctly, right? Should be all right. Okay, next part. So of course, this one will be using the other formula, right? Because you don't know how many terms there are. So you only have the last term, right? So this one is the L, right? This one is the A, okay? So we don't need to know how many terms there are, but we are still able to find the sum, right? That's the beauty of the formula. So Sn, we don't know what n is, so I'm just gonna skip it or just write S, okay? So S equals to, the formula is A minus L R, right? Over 1 minus R. Okay, so we're plugging the numbers now. A is 12. L is 3 over 64. Ratio, okay, what's the ratio for this one? Eric?
1/4.
1 over 4, very good, okay? It gets smaller each time, right? Multiply by 1/4. So over 1 over 1 over 4. Okay, so try this again. Please raise your hand when you get the answer for this. Okay, this one, I think you can leave the answer in fraction. Okay, so leave it as something over something. Okay, improper fractions. No decimals. Okay, this one is not too many terms, right? Put your hands up if you finished. Okay, Kelly, any trouble? Samantha, any questions? Typing in. Okay, Donna, what do you have? Final answer.
1023 over 64.
Over 64. Okay. Eric, how about you?
Same thing.
Same thing. Okay. Any trouble there? Kelly and Samantha, are you able to get the answer?
Yep.
All right. Okay. So one more. Okay. So this time by yourself. Okay. Same as before. So S equal. Okay. You type that in by yourself and we'll check. I see someone already finished. So this time, same thing. We are able to leave it in fraction, okay? It's not too bad. Okay, let's have Cindy tell us your answer. What do you have?
34,125 over 256.
256. Okay, that's good. Does anyone have question how to get that number? This one is correct. Okay, Kelly and Samantha, you're good? Okay, so that's all for the formula, okay? So much easier, it's less things to worry about compared to sequence, right? Sequence, they have many kinds of questions, right? They could use variables, right? Starting from the middle, right? But for this one, it's pretty straightforward. Just know when to use which formula. Now we have one more topic about series. Okay, it's called infinite. Infinite means it keeps on going, right? Doesn't finish. So, for example, like this one, right? The example we had. If I want to keep on adding and adding, right? You can see that the number keeps on getting bigger. So the more you want to add, right? The more terms, the bigger the sum, right? Each time you are the number is multiplying by 3. Okay, so if I try to go on forever, it will be impossible to have a total, right? Okay, so how are we going to find a sum if it goes on forever? So that's what this part is talking about, right? Seems like it's gonna blow up, right, as we move on. So let's look at a story here, okay, a scenario. So let's have Eric, can you help us read this out? Suppose that
you are asked to walk toward a door which is 100 meters away. However, you approach the door by first moving half the distance to the door, then moving half the remaining distance, continuing to move half the remaining distance for as long as possible.
yeah, okay. For as long as possible means infinite, right? You keep doing the same pattern forever, all right? So let's draw a picture, okay, to see it visually. So let's say you're standing here, right? And this is the ground, and then you have a door, right? And you try to get out, right? So the door is 100 meters away, right? So let's put that here to here is 100. You approach the door first by moving half the distance to the door. Okay, so what's your first step? How far do you go then? Irae?
50 meters.
Yeah, you will be moving 50 meters in your first move, right? Half the distance. So your first distance is 50, and then you stop, right? Now to make the second move, you have to move half the remaining distance, right? So how far would you go next time? Cindy? Cindy, how far is the second move?
50.
50 again? then we'll be at the door already. Right? Is that what it says?
Oh, no.
First, it moved half the distance to the door, so 50, right?
25.
Yeah, okay. Because the remaining is 50, but you only want to move half of it, right? Half of the 50 is 25, okay? So you still have another half, right? And I continue do the same thing, right? Continue move half the remaining distance again, over and over, okay? So what is the third move? How far is the next one? Donna?
12.5.
12.5, yes, okay? Half of the 25, right? So I'll get 12.5. Okay, and I do the same thing again. Half of 12.5, right? And then half of the next one. So if you keep doing this forever, because you are very bored, so you keep doing this forever, will you be out of the door? Will you be outside the door? Kelly, what do you think?
Like cross the door?
Yeah, will you be able to get out of the door?
No.
No, right? Because there's always a remaining little space, even though it's very tiny, right? But since the rule tells you to only walk half the remaining, so there's always something remain, okay? But then it will be so close to the door so that it feels like you're at the door. Make sense? Okay, so question 1 here, it says, write the sequence of distance moved in each step, okay? And then find the total distance traveled. So the sequence here, the first one is 50, right? Second one is 25, 12.5, half of that 6.25, and so on, right? And total distance means I will add them up, plus, plus, plus. And because it goes on forever, we write as infinite, right? That's infinity sign. Okay? So what do you think the total should add up to then? If I keep on adding all the red numbers, right? 50, 25, 12.5, and so on. If I keep on adding bigger and bigger, right? More and more numbers, what do you think it will be equal to? Anybody? Think about this. Look at the picture.
100.
Yeah, okay. Because you are eventually so close to the door. So that means you've traveled 100 meters, right? But even though you are still like a little bit away from the door, but probably is so close that you can ignore, right? Because you are doing this infinite. Okay, so we'll just say the total is 100. Okay, the little tiny remaining distance, we just ignore that, it's too small. Okay, so now the question is, if you are given a series like this, right? Here's the question, right? 50 plus 25, blah, 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 right? How can I find the answer of 100? Right? Because we know it's 100 because we know from the beginning it's 100 away. So here we want to derive a formula, okay, so that we can figure out the 100 using the formula. Okay, so let's use the formula that we already know, okay? So look at this question. We'll copy the question again. S infinite is 50 plus 25 plus 12.5, right? Dot, dot, dot. The only two formula we learned so far was these two, right? Number 1 and number 2. Okay? So what do you think? Which formula we should apply? Number 1 or number 2?
1.
Number 1 because
It doesn't have the last term.
Very good. Okay, we don't know the last term, so let's apply the first formula. First formula looks like this, right? A, and then, okay, so can everybody please plug it in right now? Not a calculator, okay, just fill in the blanks. Okay, when you finish, you can raise your hand, okay? No calculator. Just fill in the numbers into the blanks. Okay, so you will see that one of the blank, you don't know what to put in, right? Which one? Which one we don't know? Which one I cannot put it in? Anyone?
The exponent.
Yeah, exponent, right? Because the exponent is supposed to be a total number of terms, right? But then this one goes on forever. We don't know how many there are, right? So we'll just fill in everything else. So 50. The ratio, what's the ratio here, Cindy?
1/2.
Yeah, 1/2, okay? And then the n is the number of term, we don't know, right? And then over 1 minus r. Okay, can you raise your hand if you got to this point? All right, so now let's think about what happens if the number of term gets to infinite, okay? So I'm going to erase this exponent now and add it as infinite, right? Because it goes on forever. So that means it's multiplying by half forever, okay? So I'm gonna grab this out to the side, okay? And think about this. If I take 1/2 and then raise it to the exponent, that's really big, okay? Let's say not too many. Let's say we just do 50, okay? I don't know even if the calculator can calculate that. Maybe too big, okay? Let's do something smaller. Let's say just do 10, okay? So can you guys plug it into calculator and tell me what you have? Okay, raise your hand if you got that number. 1/2 to the 10. Okay, Donna, what do you have?
Decimal or fraction?
Both.
Okay, fraction 1/1024.
Okay, and decimal?
Wait. Zero point 0.0009765.
Okay. Okay, so I just
625.
write 97. Okay, 97. Okay, 9765. Okay. Yeah, so looks like it's really tiny, right? So if I try to make the exponent even bigger, right? Even like just 20 then. What do you think the number is close to now? It'll be close to what? What do you think? Tiana? If the exponent gets bigger and bigger, right? 1/2 to the 20, what's that answer gonna be close to? Tiana? Any thoughts?
I don't know.
You want to try it in the calculator?
I already have it typed in a calculator.
Yeah, and?
1/1048,576.
Okay, so if you turn that into decimal, that number is really close to what? Is it a big number?
No.
Okay. So is it a small number?
Yeah.
Okay. So it's a number that close to what? If you
Close
round it, yeah,
2.
close to 2. So almost 2.
No, like it's 9.5 times 10 to a negative 7.
9.5, 9. Okay, 9.5 times 10 to a negative 7. What does that mean? Do you know what's the, what does it mean? Have you seen this kind of symbol? Times 10 to a negative 7?
Yeah.
Yeah, so what does it actually mean? What's the value of it? If I want to get a decimal answer, what should I do?
Like you put zeros, like 7 zeros behind 9.
7 behind 9.
Or like you count
Okay.
backwards 7
So you
times.
tell me what to write. 0 point.
0, 0, 0, 0, 0, 0, 95.
95. Okay, so what do you think? This number is close to what value? Almost what? Don't be afraid. Just say out what you think, and I think you know you have something in your mind.
I don't know.
Huh? No? Okay.
No.
Let me ask. Cindy, what do you think? What's this number close to?
0.
0, right? Tiana, do you agree?
Yeah.
Yeah, right? So it has a lot of 0. It's just a little bit bigger than 0, so it's close to 0. Okay? So the bigger the exponent, the smaller the whole thing will equal to, right? So we can basically say if the terms goes on for infinite, right? This whole thing here will go to 0. It disappears. Okay? Because half times half times half, the result will get smaller and smaller. Okay? You got to do imagination here. Got to have some imagination here. And then because that part turns to 0, then what's left? It will be 50 times it by 1 minus 0 is just 1. So I'm going to just skip writing 1. Okay? So it'll be 50 over 1 minus half. Okay? And let's take a look, find the answer. Okay? 50 divided by 1 minus half is half, right? So here we have 50 divided by half. 50 divided by half. Divide by half. Okay, let me erase this part. Divide by half is the same as 50 times the reciprocal, right? So that is 100. And that 100 is what we said before. 100. Okay, so how can we get 100 now? Let's look back at the formula. I want you to look at this green box. The 50 represent the first term, right? And then the ratio is the 1/2. So we could have a formula for any infinite, right? So S infinite, okay, you can put inside the box, or equal to 50 is the first term, so A over 1 minus R. Okay, so that's where you get the formula. But then as I mentioned before, right, if the terms gets bigger and bigger, okay, like the first example we did, then you won't be able to add up everything forever because it gets bigger, right? You can only use the formula such that the series, it gets smaller, right? Each term, it gets smaller. This one is getting by half, okay? So what kind of ratio will make the number become smaller each time? Okay, we need to have some restrictions, right, on the ratio. What kind of ratio can make the term become smaller every time? Think about this. What should be the restriction on the R? Anyone?
Smaller than 1.
Yeah, very good. Smaller than 1. Right? For example, like half. Half is smaller than 1, right? If I try 2, then every time you times it by 2, it gets bigger and bigger, right? So it has to be smaller than 1, like 0 point something. But is it any number smaller than 1? Can I go as small as possible? For example, can I use like -10? Right? -10 is smaller than 1. So is there a limit to how small the ratio can be?
Yeah.
Yeah, what did you say, Donna?
It can not be smaller than -10, so it should be bigger than -1.
Bigger than -1, yes. Very good, okay? So it has to be in between, okay? You can write it like this, in between -1 and 1, okay? If it's -2, it will also make the sequence, okay, or the terms blow up, right? Think about if you start with 50 and you multiply by -2, it becomes -100, right? And you times -2 again, it becomes 200, and then 400, right? It gets bigger and bigger in a negative, on the negative side, right? So it has to be between -1 and 1, okay, for it to work, all right? So if it's not in between -1 and 1, then you will say the sum does not exist, okay? So this part, I need you to make a note, okay? -1 and 1, let's write it this way, okay? Let's erase this. Okay, so if R between -1 and 1, sum exists. Okay, we have the sum. If it's not between 1 and -1, okay, not between -1 to 1, then you will have sum doesn't exist. And we also have a name for that, okay? It's called the infinite sum, okay? The sum goes on forever, okay? It doesn't have a limit, right? The example we had here, the limit is 100, right? We can get a finite sum. So the sum, when the sum exists, you can also call this the finite or finite, okay? Finite sum. Okay, any questions? Can you raise your hand if you finish writing here? Okay, so let's have a break, okay, for 15 minutes. And I'll see you guys at 6:30, okay? Bye-bye.